All right, guys. Today we're going to be talking about, we're going to introduce this new term, ions, another I word. You remember some week or so back we learned about isotopes. Those are atoms of the same element with different number of neutrons and thus different weights. But ions is different, so don't get those confused. Hopefully this doesn't look new to you. This should look familiar. This is that orbital filling diagram. You guys remember we're talking about atomic structure and primarily electrons, because how many electrons and where those are located determines an element's chemical properties, so that's why it's important to know. This shows you remember electrons can exist in orbitals, those are spaces around the nucleus, and there's different orbital types. You guys remember s orbitals are spherical, p orbitals are like pear-shaped, and then d and f, and they get kind of funky. And these are all the different spatial arrangements around the nucleus in where you can find electrons. And this shows you the order in which the orbitals are filled. So you guys, we're going to practice one. So for example, we had nitrogen. This was on one of your homework. So remember how you do nitrogen. You look on the periodic table, you can see nitrogen has 7 protons. So if it's neutral, it has 7 electrons. The question is, where are those electrons located? Well, we use our orbital filling diagram. Remember, you fill them like this. So the first electrons are going to be found in the 1s orbital. So you guys remember, each orbital can hold up to 2 electrons at least, as long as they have opposite spins, and we'll indicate that with arrows. And then after that's filled, so now that's filled, now they fill the next orbital of lowest potential energy, which is the 2s. And that can hold 2 electrons. And then once the 2s is full, then they begin to hold the 2p. But you guys remember with the you remember the p orbitals, remember it's kind of interesting, they can be on the x-axis, the y-axis, and the z-axis. So there's actually 3 p orbitals. And so you guys remember how they get filled. Each electron wants to occupy an empty orbital first before they pair up, because electrons want to be as far apart as possible, okay? And so it would look like this. You guys remember the abbreviated way would just be to write it 1s2, 2s2, 2p3. That's the electron configuration. Guys, let's do another one. Let's do sodium. Sodium has 11 protons, and thus neutral atom has 11 electrons. So once again, you guys are going to fill it in the same way. You guys, you'll see, as you do a few of these, it just becomes even somewhat redundant. The first 2 electrons fill the 1s, then the next electrons are going to fill the 2s. You guys see why this is? Like, think about this. I have some sand here, and have a graduated cylinder. Let's say, obviously, if I pour the sand in there, where is that going to go in the graduated cylinder? Isn't the sand going to go, as you guys should have guessed, it's going to go to the bottom. I don't know if you guys can see that. It's going to go to the bottom, right? And why is that? Because that's the place of lowest potential energy. Some would say due to gravity, right? Doesn't the sand want to be closest to the center of the Earth due to gravity? In the same way, where do electrons want to be? As close to the nucleus as possible, because the nucleus has protons which are positively charged and electrons are negatively charged, opposites attract. But now, let's say the sand kind of represents electrons. Let's say, right, where's the next sand going to go? It can't go, to the bottom, because that's already occupied. So where is it going to go? Isn't it going to go on top of the existing sand? It's going to go to the place of next lowest potential energy. And then where's the next sand going to go? It's going to go to the place of next lowest. And so now it's at this level. I don't know if you guys can see that, right? So in the same way, that's how electrons fill orbitals. So then 2 electrons go in the 2s. The 2s is full. Then the 2p. You guys remember, once again, there's 3 of them. And you remember how they fill. Look, they're going to fill individually first. But then, you guys see we've accounted for 7 electrons here. There's a total of 11. So where do the next ones? Now they begin to pair up again. But now, those orbitals are full. So where would the next electron go? We have 1 more left. Is there 10 here? There's a total of 11. Where's that last one going to go? After the 2p, it's the 3s. And that would be, here's the electron configuration. 1s2, 2s2, 2p6, and 3s1. What we've done is we've located where all those electrons are found. You guys, here's another chart, and I don't want you guys to get thrown off, but this chart is really the same as this chart. It just shows it in a different fashion. You guys, think about, like on this chart here, let me see if I see what you're looking at. Yeah, okay. You guys see, it's still the order. This is, for example, this is potential energy, right? So down here is the lowest potential energy, here's the highest. You might look at down here, think of down here at the bottom, That's like the nucleus of the atom, right? Where all the protons are, right? And think about the electrons kind of arranging themselves. And so you guys just kind of follow and look at sodium here. We'll just fill this up, right? We have electron here, 2 electrons, see in the 1s. And then you guys see, notice I put lines here because that indicates, and we're going to introduce a new term to you guys here. But basically there is a, in fact, we're going to show that right now. You guys write this down. Here's the term shell. A shell, we're going to use that term, is includes all orbitals of similar potential energy. And I'm going to abbreviate potential energy with a PE, okay? So that's potential energy. So for example, this kind of represents one shell, and then look, then the next electrons would be in the 2s orbital. Next electrons are in the 2p, right? They fill 1, 2, 3, and then here. But you guys see, for example, look, this represents one shell of electrons. This represents another shell. See how the 2s orbital is slightly lower in energy than the 2p, so it gets filled first, right? Remember, electrons are going to tend to want to be in the place of lowest potential energy. It's like a book. We did this before. Where's the book going to want to be? It's going to go to the bottom, right? Because down here, it's a lower potential energy, and here it goes from a higher potential to a lower. So, and then you can see the last one is right here. So just to see if you guys are following, how many total shells of electrons does sodium have? I hope you would say 3. It's got electrons here in this first shell. You guys notice there's a big energy gap here, and then you guys see there's a small energy gap here. So this kind of makes up what we call a shell of electrons. So 1 shell, 2 shell, and then it's got 1 of these electrons in this third outer shell. That brings up another question, or another term, valence electrons. You guys remember how I abbreviate electrons with an E-? Valence electrons are electrons located in outermost shell. Okay, so then see if you guys understand this term. I would ask you, well, how many valence electrons does sodium have? How many valence electrons does sodium have? And you should be able to tell me, oh, it's got 1. Look, it's got 3 shells. Remember, it says the electrons located in the outermost shell. So it's got the third shell of electrons here, and it's got 1 electron there. It's got 1 valence electron. And you guys, the valence electrons are really important because those are the ones that are going to tend to be gained or lost or shared, which we're going to be talking about here shortly. So those are the important ones, okay? Here's another term called core electrons. And these are the electrons located in the inner shells. Notice I say plural. Those are all the electrons in the inner shells. So for example, if I said, how many core electrons does sodium have? You should be able to tell me, oh, it's got, because you guys look, it's got 3 shells. So wouldn't the first shell and the second shell be the inner shells? Those are the ones where the electrons are closer to the nucleus. So it's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's got 10. So basically, you guys, of all the electrons, the core electrons are all the electrons that, apart from the valence electrons. But once again, what are the most important electrons? It's always the valence electrons. Those are the ones further from the nucleus. Those are the ones that tend to be gained, lost, or shared. Okay. Here's one other thing, you guys. This is really important to note. Here, I'm gonna, you know what? I'll put it down here. Guys, make sure you put this. Atoms. I want to actually see if you guys can actually see this. Yeah. Okay. Well, this color's not really good. Atoms. This is very important, guys. Tend to gain or lose electrons in order to fill their outermost shell. So you guys definitely write that down. That's really, really important. This kind of helps us to determine and predict how atoms are going to behave. Okay, so write that down. Oh, here, you know what? I should have I'm going to keep these here. Nitrogen's 1s2, 2s2, 2p3, and sodium was 1s2, 2s2, 2p6, 3s1. Okay. So, you guys, we're going to use this to try to make some predictions. So now, I want you guys to look. So this was like the electron configuration of sodium. See, it's kind of the same thing, okay? So now I want to predict, what would I predict would happen to sodium? What do you guys think? Atoms tend to gain or lose electrons in order to fill their outermost shell. So I would look at sodium, and I look, it's got one electron in its outer shell. Is its outer shell full? No, and you guys see the third shell consists of both s orbitals and p orbitals, right? Those are different spaces around the nucleus. It's not full, so what I would expect, the question is, there's one of actually two things that could happen. What could potentially happen to sodium? Couldn't it potentially, here, we'll use a different color. Couldn't it potentially gain 1, 2, 3, 4, 5, 6, 7? Couldn't it potentially gain 7 electrons? Because wouldn't you guys agree now that third shell is full? You guys see, that's what atoms tend to gain or lose, because there's a certain stability associated with full outer shell. So it could gain 7, or, hoping you guys could predict correctly, what else could happen? Or it could just what? Lose 1 electron. Wouldn't you guys agree? Because look, if it lost 1 electron, now it doesn't have any electrons in the third shell, and you notice now it just has it only has 2 shells of electrons, and the outer shell now is full. So the question then would be, what do you guys think is the more likely scenario? Is it more likely to gain 7 electrons? Is that nucleus going to attract 7 electrons? Or do you think it's more likely that it's going to lose 1 electron? Hopefully you guys correctly, it's more likely to lose 1 electron. That's indeed what sodium would do. Sodium would tend to lose 1 electron. And now you guys look what happens. Okay, so here sodium, right, a neutral sodium atom, and you guys, if you look on the periodic table, it has atomic number 11. So that means it's got 11 protons. And if it's neutral, what that means, overall it doesn't have a charge. That must mean it has 11 electrons. So you guys look, once again, overall, what's the charge? It has 11 positive charges and 11 negative charges. When you guys agree that overall charge is a 0. So you could really put, you could just leave it like this. You could put like a 0. We'll just leave it, okay? But now, okay, so it loses 1 electron. So, okay, it loses 1 electron. Okay, so now, if that lost 1 electron, now how many protons does it have? Okay, you're right. I was kind of fooling you, okay? So it's still sodium, okay? It still has 11 protons. You guys remember, look, nothing happened to the protons in the nucleus, right? Just think about it. Those are kind of stable there, right? Well, you guys, if it had 11 electrons and it lost 1, now how many electrons does it have? Now, would you guys agree it has 10 electrons? So now you guys look, if it's got 11 positive protons and only 10 negative electrons, now what kind of charge does sodium have? It has a negative, oh, I'm sorry, don't want to confuse anyone. When you guys agree a positive 1, because it's got 1 more positive proton than electron, we'd say the sodium acquired a +1 charge. You guys see how that works? +1 charge. Guys, I'm going to try to get a little bit more room here. Hopefully you guys wrote that down. Let's look at nitrogen now. Now we want to predict. So you guys see, this is where if we have some understanding, we can move on from the next level of understanding to then make predictions. Okay, so let's think about it. Nitrogen, this is the electron configuration, right? 1s2, 2s2, 2p3. 1s2, 2s2, 2p3. So once again, we should be able to predict. What do you think might nitrogen have a tendency to do? Once again, you guys remember, I erased it, but atoms tend to gain or lose electrons in order to fill their outer shell. So what could happen? Hopefully you guys guessed. Oh, it could. Do you guys agree? Couldn't it gain 3 electrons? Right? Could gain 3 electrons, because now wouldn't you guys agree that second outer shell is full? Or what could it potentially do, guys? Or it could potentially what? Lose 5 electrons. You guys see now it doesn't have any electrons in the second shell, it just has them in the first shell. So, what do you guys think is the more likely scenario? Is it more likely to gain 3 electrons or lose 5 electrons? Hopefully you guys guessed correctly. The tendency is for it to gain 3 electrons. Because when you guys agree now, its outer shell is full. So we're going to predict it would gain 3 electrons. Okay? So then we want to see, okay, what happens to the nitrogen? So you think about it. Originally, nitrogen has a atomic number of 7. That means it has 7 protons. If it's neutral originally, right, neutral just means it has the same number of electrons as protons, and it must have 7 electrons. And you can see, once again, 7 positive particles, 7 negative. Overall, it's a neutral nitrogen atom. Well, we just predicted it's going to gain 3 electrons. So now, how many protons does it have? Okay, once again, trick question. It still has 7 protons. There's nothing changed. It still has 7 protons. But now it has how many electrons? You count all those, and it's got 10. Overall, guys, what is the charge on that nitrogen atom? 7 positive protons, 10 negative electrons. Overall, when you guys agree, it has a -3 charge. -3. So we went from a neutral atom here to a positive atom. We went from a neutral atom to a negative atom. That introduces 2 new terms here for you guys. Okay, here we go. You guys write this down. Ions, that's our term here. Ions are simply atoms with a charge. That's what ions means. Okay, so now you know. So if an atom gained or lost electrons, it becomes what we call an ion, an atom with a charge. And notice how these now are ions. They have a charge, whereas before they were neutral. Okay, almost done here, guys. If an ion is a positive ion, we call that a cation. You guys, those of you guys who are cat lovers at home, think, oh, I love kitties. I get a warm, positive feeling when I think about cats. Positive ion, cation. And then negative ions, however, are called anions. Anions. And you guys think about it, what does anion kind of remind you of? Maybe an onion. A lot of you guys maybe at home, you don't like onions. You're like, oh, onions give me a negative feeling. I want to throw up. I don't like them. They smell nasty. You think negative ion, anion, onion. Now, if you hate cats and love onions, this ain't going to work for you. But if you love cats and hate onions, that might work. Okay? So those are some new terms: ion, positive ion, negative ion. We talked about valence electrons, core electrons. All right. Last thing. Ultimately, guys, I want you guys to think. Okay, so this will just start here. Ultimately, I want you guys to think. Okay, here's the last question that we should be able to do. Looking at an electron configuration, like here, let's go with this. Let's go with sodium here. Okay. Go with sodium here. You guys should be able to tell from the electron configuration, ultimately this is what I'm hoping you'll be able to do, how many valence electrons. Remember, of all the electrons, it's the valence electrons that are important. Those are the ones that can be gained or lost, so those are the ones we're concerned about. So we should be able to look at an electron configuration and tell how many valence electrons there are just from the electron configuration. Obviously, if you guys have a chart like this and I ask you how many valence electrons does sodium have, you'd be like, oh, it's got 1. You guys are right. You just go to the outer shell and you're like, it's got 1. That's easy. But let's say you're not going to have this chart available for you at all times, right? All you would have is this electron configuration. So the question is, how do you think you would determine how many valence electrons from the electron configuration? I know what somebody might say. They're like, oh, don't you just go to the last orbital and it says it has 1 electron there, so wouldn't that just have 1? That seems to work, right? But let's look at nitrogen. Okay, here's nitrogen. If I use that same kind of thinking, so this was nitrogen, right? If I use that same kind of thinking, what would I say are the number of valence electrons in nitrogen? When you say 3, and you guys, is that true? Are there 3 valence electrons? No, that's not true. How many valence electrons are there, guys? This is the second shell. Remember, it's all the orbitals that have very similar. See, 2s is just slightly lower in potential energy, but that makes up a shell of electrons. When you guys agree, it has actually 5. It has 5 valence electrons. So can someone then think, can you think, what kind of strategy can we use to determine which ones are valence electrons? And here's what I'm hoping you guys came up with. If you notice, what does each orbital begin with? What does each shell begin with? What type of orbital? You guys see that? Look. Each shell begins with an s orbital. So you know what? That's how you're gonna know when a new shell begins. So what do? You simply go, oh, and you'll notice, you guys notice there's a big gap in energy, between shells, right? And you guys notice, and that's why technically what we should do is we should put, every time a new shell begins, and how do we know a new shell begins? With an s orbital, we put a line here indicating there's a big energy gap between there, right? And then here I put a line here, but then guys, where do I put another line? Don't I begin it right here? Because this begins the first shell, this begins the second shell, this begins the third shell. So what do? You don't just go to the last orbital to figure out how many valence electrons, you go to the last shell, and how do you know that? You go to the last s orbital and count all the electrons after that, because that indicates the electrons found in the outermost shell. So I go to the last s, which is right here, and I count 2, 3. How many valence electrons does nitrogen have? It indeed has 5. All right, guys, so that's what you guys are expected to know. We will see you guys next time. Bye.